All right, I'm going to make some another video here on exponent rules, so you get a little extra practice if you want to clarify your rules on these. So first thing I'm going to do is I'm going to drag out. I got these from your extra practice online at the CPM website, cpm.org website, and so you can find all these there also. So I just copied and pasted them, and I'll just go through these kind of quickly. I put this in the corner here to help you if you want to refer to that at some point. I'll touch on that when I need to. So first one, we have y to the fifth times y to the seventh. If I'm going to break this down. The quickest way is just to use these formulas. But just so you understand this, the y to the fifth is 5 of these. The y to the seventh is 7 of these. So all together, and it's multiplication all the way through, even that one. So how many are there? There's 12 of them. So that's just y to the 12th power. Okay. This is saying if you have two of the same base, like we have y's here, the powers, you just add them. A plus b, 5 plus 7. So the shortest way, obviously, just do 5 plus 7. All right, let's make that bigger. And the next one. Now, when there's only one base, there's a single base number, this y, and two powers, then I'm looking at this rule here, where it just says to multiply the powers. So this is y to the fifth squared is just y to the 10th. Okay, now the reason this works, squared just means times itself, so it's y to the fifth times y to the fifth. Well, if you actually write them out, there's 5 here, and there's another 5. Altogether, there's 10 of them. So that's another reason, or another way to show that answer. Let's do number 5 from your extra practice problems. If there's two things inside, you need to, it's almost like the distributive property. It's not technically the distributive property, but you're putting the 4 on both parts. So you put the 4 on the 3 and the 4 on the a. So this would be 81 a to the 4th. Don't make it 12. Because this 3 to the 4th is 3 times 3 times 3 times 3. I just kind of did this in my head or have it memorized. All right. Number 6. Now, you can use this rule over here where it has x to the power of a and over x to the power of b. And then that reads right there x to the power of a minus b. But you can also visualize, I guess, 8 m's on top. I'll just show this at least once. 7, 8, and 3 m's on the bottom. It's all multiplication everywhere. We can cancel like this, and you're left with 5 m's. Okay, it's not 5 m's, it's m to the 5th power. Okay, because we're multiplying, not adding. And the m's are on top. That's important because if this was flipped, if this was m cubed over m to the 8th, we still subtract, but we're going to end up with 5 m's on the bottom, not on the top. So this problem would have been like this. But this particular one that they gave us is just m to the 5th power. Okay. Let's do this one. Now a couple different ways here. I guess I prefer to move this m cubed, or m to the negative third, up to the top, and think of the 12 and the 6 as separate numbers. So this is like 12 and 6 just like normal numbers. 12 divided by 6 is 2, or think of it like a fraction. So it's like 2 over 1. We'll put that there for now. There's an m to the 8th on top, and there's also this m to the negative third that I need to move to the top. That negative sign means reciprocal. Reciprocal means flip, so move it to where it's not. So then you just simply combine. So combine those together and make that an m to the 11th power. Just using that rule. Now the other way to do this problem is just use the division rule here, where you subtract the powers. So you could just do the 2 like we did before, and then m to the 8 minus negative 3. You're just subtracting because it's division, and then minus the negative, which changes into an 11 that way. So whichever you prefer. Kind of going through these quickly, so pause whenever you need to pause. All right, just put the 3 on both parts again. Okay, so x to the 9th y to the 6th. That's it. That's simple. Again, at any time, pause and don't let me explain it. Try it on your own and then compare your answer to mine. Here, there's nothing outside the parentheses here. If I'm just taking this separately. So I just simply have 4xy squared. So I'm not going to change it. This 3 has nothing to do with that set of parentheses. But I will put it on this part. The 3 goes on the 2 and the y. So it's times 2 to the 3rd y cubed. This is an 8. So I'll combine my 8 and my 4 right away. Just make that a 32. Now I have an x, and I have these two y's I need to combine somehow. You can't have an answer that looks like this. So make sure you combine the y squared and the y cubed together and make that a y to the 5th. You can't have two y's in your answer, or two x's, or two of anything for that matter. Always combine to a single letter if you can. Okay, there's times in each of these. I would just write 32 x y to the 5th power. Oops. Let's try that again. And 14. That 3 goes on both parts. Boom, boom. So it's 4 cubed over x to the 6th, because you multiply them. So that's just 4 times 4 times 4 over x to the 6th. Can't really do anything else with that. Getting there. It seems more complicated here, but it's just more tedious, not more difficult. The 2 goes on every single part. So 3 squared, a to the 4th, x to the 6th. And the 3 goes on all three of these things. There's 3 separate parts here. So 2 cubed, a cubed, because there's like a power of 1. It's like saying 1 times 3 if you want to use that rule. And then x to the 12th. Now we need to simplify it. Make these numbers like normal numbers and combine them. So this is a 9. That's an 8. 2 times 2 times 2. So together I have a 72. Make sure you multiply, not add. And if I look at my a's, it's all times. Okay, so the rule is we're right up here. We're going to add the powers. So it's 4 plus 3 is 7. So I have a to the 7th, and then my x's, x to the 18th. All right. Now a negative exponent's a little bit more, on its own here. X to the negative 3rd, just by rule, is 1 over x to the positive 3rd. That's all. It's just reciprocal. It's the reciprocal of this. Right now it's on top. You don't see a fraction, but it's like over 1. So circle it, bring it to the bottom. Don't forget to have a placeholder on top. So it's 1 over that. In a problem like this, the 2 does not have a negative exponent. It's actually 2 to the 1st, x to the negative 3rd. So all we're going to move is the x to the negative 3rd part. The 2 stays on top. So it's 2 over x to the positive 3rd. Hopefully that makes sense. 3 more. All right, a couple different ways to do this problem. One way, in fact, I'll copy it and do it 2 separate ways here. Let's get rid of this. Some more space. One way is to flip it right away. So this negative exponent means the whole thing to the positive exponent, but the reciprocal of that. Like this. So it's 1 over 2x to the positive 3rd power with parentheses. The other way is to distribute the negative 3rd right away. So 2 to the negative 3rd, x to the negative 3rd, and then circle them and move them kind of like separately. Either way, at this point, like this 3 then needs to be distributed. I can keep saying distributive. It's not really distributive, but put the 3 on both parts. So it's 1 over 2 cubed, x cubed. Over here, move it to the bottom. It's 1 over 2 cubed, x cubed. So either way, we get to the same point, whichever you prefer. 2 cubed is 8, so it's just 1 over 8x cubed. And make sure you simplify. And whenever you have a number to a power, just get the answer for it. 2 more to go. And here's a quickie. You just have anything to the 0th power is 1. That's it. So if it's like within a problem, 2x cubed plus 9x minus 4y, all this to the 0th power, it doesn't matter what that is unless it's a 0. It can't be 0. But to the 0th power, the whole thing is 1. So just all replaced. Okay. You have to be careful in problems like this. Like if it's 2x to the 0th power plus y to the 0 or something like this. You got to be careful. This whole thing isn't 1. It's only this part of it. It's like saying 2 times 1. And then don't ignore this because that's still a 1 and we're adding 1 to something. So this is 2 plus 1, which is 3. So they could try to fool you with something like that. And of course, keep in mind x and y can't be 0 here. And our last problem, thank goodness here. Hope you didn't fall asleep yet. Either flip it first and make it positive, like I could actually do 3 over 2x to the positive 2nd power, like because it's a reciprocal, so you can just flip both parts over, or you can put the -2 on each part separately and then flip. I don't know what you prefer. This seems quicker for me. 2 to the -2nd, x to the -2nd, 3 to the -2nd. You can do them all like this, and then that goes to the bottom. That goes to the bottom. This goes back up on top. Okay. When I do all that, I'm going to get what I just did here: 3 squared on top, 2 squared on the bottom, and x squared on the bottom. So whichever, that goes there and that goes there. We get to the same spot. Eventually we get to 9 over 4x squared. And I do prefer to have a single fraction. Try to avoid this. I mean, it works. It's the same thing. These are actually equal to each other. That's supposed to be a 4. Still left well enough alone. But I prefer the 1 fraction. I wouldn't mark it wrong if you put the other one. All right, bunch of problems. Not a bad idea to go back and try them all again on your own and check your answers. Thanks.